Alright, so last time we developed this advanced foliage spawner with the do intersect function and the orientation function, and as for the moment it can't still distinguish which points are inside this polygon and which points are outside this polygon. So today I'm going to cover that part using by using the equations defined in this article. So basically the logic is, if a point is inside a polygon, then when we connect that point with some other point outside that polygon, lies outside that polygon, then that line intersects an even time if it is outside the polygon, and it does intersect an odd number of times if the point is inside the polygon. So that's the theory we are going to use. Okay, now we already have a method to find if we give two lines, that means 4 points. P1 Q1 is the first line and P2 Q2 is the second line. So when we give 4 points which defines the two lines, this will return either true or false based on to show that if these two lines do intersect or not. Okay, so yeah, right now, yeah, in the construction script, this is what we have done up to now, and this is the temporary point that we need to figure out, that we need to determine if it is inside the polygon or outside the polygon. So I'll promote this to a variable like this. I'll call it p temp, I think, and I'll use that point instead of the result of this one. Okay, and now I'll create another function is inside polygon, and I'll add an output of the type boolean yes, no. This will return either if it is yes or no, and I'll use this function here, is inside polygon. We need an input of the type vector, because we need to give what is the point that we are considering, what is the point that we need to check if it is inside or outside the polygon. I'll call it P, and I'm gonna put P temp as the P, and I get the result. So, and after that I'll do a branch, and I will draw this line trace, that means these lines only if it returns true. So yeah, at the moment it returns, but it doesn't return true. Alright, so it doesn't draw those lines anymore, because those lines I saw were the lines drawn in the previous try, because I have put tour time as 50. I'll make it 5, and if I compile now, you don't see any lines because this always returns false, because I haven't implemented that function yet. Okay, so how do we implement this function? Well, yeah, we can do it like this. Let's so the edges of these polygons, that means this one, this one, this one, and this one, and also I will get an imaginary edge which connects points, which connects this point and the first point. So in order to determine if there are the total number of intersections that the given point and the imaginary another point, the line created by this point and another point which lies outside the polygon, to determine that we need to check the intersections with all these edges. So for that I can do it like this. We can get number of spline points, and then we can do a for loop. First index should be 0 and the final index should be, no, not this one, actually, yeah, final index should be this one minus 1, because the index starts from 0 and the number of points starts from 1. So yeah, that's the reason. Okay, now here I'll add another local variable. I'll call it intersections. Intersection count. Okay, so right, so this is the here we need to call to intersect, and if I need to go the return node here, not here. So if this is true, I will increment the intersections count. And the final result, yes or no, is based on the odd. If this one is odd, it should return yes, that means it is inside the polygon according to this theory. If it is even, that means this given point P is outside the polygon. So how do I determine if this is odd or even? Simple. Divide, get the modulus, division, modulo, that means divide this number by 2 and get the remainder. So if the remainder is 0, that means this intersections count is even. So this should be true if this number is odd. So I should check if this is not equal to 0. If it is equal to 0, then this will return false. That means it is outside the polygon. So now how do we determine this P1, Q1, P2 and Q2? So definitely P1 is this P, and for Q1, well, we do know the minimum point on this polygon. Well, actually we used it somewhere, alright, here, but these are local variables, so they should be global variables. Then I can use it without any issue, but why can't I put it there? Oh no. Okay, forward Pmax. Can I change their scope? I can replace. Okay, so I'll define two variables like this. P min, I can't use that name because I already have used it. P min G, G stands for global, and I'll make it a vector. I will rename them later. P max G. Now let's replace. P min G. Where else I have used it? No. Okay, and we don't need this at the moment, the max point, but I will replace this also with a global variable because that way it seems neat. Okay, now I should be able to delete this. Well, actually my project crashed for some reason, so this p min thing was gone, so I created a new only p min G variable. I'll set it here, set p min G, and yeah, that would be enough for now. I can refactor the other thing later, so I can use this p min G function, not function, the variable inside this is inside polygon function. Alright, so that part is also gone, so I'll do it again. Get spline point count, sorry, get number of spline points. Okay, and for loop, starting index is 0 and return, yeah, and the final index is this value -1, and in the loop body I need to call to intersect function. So P1 is definitely this point, and Q1 should be some point outside the polygon. So I can get some point outside the polygon like this. I'll add to this minimum point of the polygon, and I'll add minus 100. So that way we know for sure this point is definitely outside the polygon, so I'll use it as the Q1. And so for P2 I'll get spline, get location at a spline point. So the spline point would be this index, and coordinate space I will use global. To make it clear, I'll use it like this. So this is P2. And what's Q2? Q2 is also the next point, the adjacent point to this point in this spline. So that means this one plus 1. But we have an issue here. The issue is, if we are at the final spline point, that means this point, then after that when we add 1 to the index of this point and try to get the next point, then we will not have a valid point because this is the final point of this spline. So for that case we should get the first number. So to make sure that we always get a valid number, we can use this trick. Divide this, not divide, get the modulus of this value by using the number of points. That means, let's say the number of points of this spline is 10, and here by adding, now we have the final index is 10. So for the P1 we get the 10th index, and for P2 we would be getting the 11th index. So but not P2, Q2. But there is no 11th index because 10 is the final index. So in that case we can get the modulus. So that means 11 divide by 10 and get the remaining number. That means 0. Oh, wait, wrong. The number of points in this spline is 11. So that's how the final index becomes 10. So when we request the 11th index, that means we don't have a valid point for the 11th index. So in that case we should get 0. So 11 divides by the number of points, that means 11, and get the remaining value, that means 0. Hope it's clear for you. Let me know in the comment section if that is not clear. I will add a more detailed answer. So that is Q2. And if we get an intersection, I'll do a branch and increment. Oh, we need a local variable, number of intersections. I had to do it again because I lost the changes last time. and in the return node I have to check if this number of intersections is odd or even, like this. Where's the percentage? Okay, if it is odd, this would be 1. That means not equal to 0, it will return true, otherwise false. Okay, so that's all, right? Right, here we made a little mistake, because if this is false we should continue. Right, now you can see we have identified, we have drawn only the points inside. So to better show it, I'll increase the draw time 50 and compile. So yeah, now as you can see, all these points are inside this polygon, nothing lays outside. Okay, so yeah, that's what we wanted to identify. And yeah, I think I'll stop this episode at this point, and in the next episode I'll show you how to place foliages on these points, because I don't want to do it, cramp that part also into this episode, because it will make this episode longer. So now, right, let me demonstrate it again. If I compare it again, you can see these points, I have determined the points inside the polygon. So if I make it, modify it like this, you can see still I only draw the points inside the polygon. Okay, and this episode is sponsored by these generous patrons, and thank you very much for the support you guys are giving me. So if you also like to support my work, you can get the membership of my patron club. Link would be in the description below, and based on the tier you join, you will have different privileges, as I have explained in this section. And also I have released a final source code release, not the final, the most current version of this procedural, well, I called it crop fields. So the system that we are working on here, you can access the source code if you join my patron club. And yeah, thanks for watching. See you in the next episode. Goodbye.